Hello, I'm Greg Hrinya, editor of LeoLED and AeroLED, and it's great to welcome you into our newest video bite, where we bring you the latest news and products in our industry. To learn more about the growing energy concerns and ways to promote sustainability goals, we'll sit down with Amir Dekel, Vice President of Sales at GEW. As the entire supply chain seeks to answer the call for sustainability, energy can often be an overlooked part of the problem. Converters need to quickly meet lofty sustainability targets that they promised, and reducing energy expenditures is one such way to accomplish that goal. To learn more about the benefits of LED curing and the problems that this technology can solve, it's great to welcome in Amir Dekel. Amir, thanks so much for joining us today.
Thanks for having me, Greg.
Absolutely. So, Amir, to start out, what are some of the biggest challenges facing converters today that you're talking to?
This is a very broad question, Greg. There are many challenges the converters are facing, but in today's world, I believe the most prominent challenge that the converters are facing would be the energy. Europe, Latin America, and some portions of Asia already experiencing it quite significantly at that point. But it is penetrating back towards North America as well. And in order to tackle this challenge, the converters need to do a lot of different things to improve efficiency and reduce the amount of energy that they use. And in fact, there are 4 different items that they can look at and improve on all of them to some degree to tackle this challenge. The first one is the installed power. The installed power is what the energy company or the electricity company dedicated for that facility or to that plant. Normally, it's very difficult in today's environment to get more than the energy that was assigned to it when the building was just built. The second one is the peak demand. Believe it or not, the electricity bill that you get, the rate at which this electricity is being charged is not by the amount of power you consume normally, but by your peak demand. The reason is very simple. The energy company must have that peak demand power available to you at any time of the day, because they don't know when you're going to need it. So since they cannot use it and sell it to anybody else, you pay for that rate. The higher the peak demand is, the higher your rate is. The third item is what's so-called the quiescent consumption, which means the ongoing consumption that you have, not the peak demand, not when you come in and power all your machines at once, but your normal consumption. You pay as dollars to kilowatt hour. And the fourth one is essentially a subsequent of the other 3, which is the carbon footprint. Carbon footprint become a lot more prominent aspect in the operation of the converter, because many of the customers are judging them by their carbon footprints, and they score them accordingly. And a brand owner, or companies like Walmart and other big retailers, they choose the converters by the carbon footprint rating, and the lower you contribute to the greenhouse gases, then the higher your score, and then you log more business.
That's really interesting. And Amir, why has LED seen such a market growth and popularity, and how can label printers benefit from this technology?
So LED turned out to be a superior curing or drying. It depends who you compare it to all other curing methodologies, especially compared to conventional UV technologies and obviously hot air. Those 2 technologies that I just mentioned consume a lot more power, and thus increase all the parameters that we mentioned, a minute ago. Now, in order to understand better why LED is superior to the other technologies, I believe we need to look at one by one on the 4 different aspects that are affecting it. So let's start with installed power. So LED technology consumes up to 65% less power than conventional UV curing systems, and even more compared to hot air drying system. So in effect, if you look at this from a practical standpoint, if you take, for example, two Flexo 17-inch printing machine with 8 color station, and you run them with conventional, by moving to LED, you can essentially add a third Flexo machine, 17-inch, 8 color, the same type, and still stay within the power consumption that all 3 presses would have had they had a conventional UV systems. So what it means is that per unit of production, your efficiency is increased by 33%. And this is significant. On a peak demand aspect, from the very same reason, 65% power, that means that your peak demand is reduced by that amount of power that is being saved once you move to LED. And remember that the electrical company, they charge you by that peak demand. The rate, your kilowatt hour is by that peak demand. So once you remove that peak demand, the electrical company does not have to place that power available to you at your curbside transformer, and thus they can take that power and sell it to somebody else. By the way, they don't lose sleep over that. They have a lot of people that want power, and as soon as you reduce your peak demand, they take it immediately and give it to somebody else. The third aspect is the operational power. This is what we mentioned before, is the dollar per kilowatt hour. Now, again, reduction in power entails reduction in the quiescent, and reduction in the quiescent means less money that you pay to the electrical bill. And in general, electrical bills are, we call them gift of God. When they come, we pay because we have no other choice. If we will not pay, they're going to shut us down. So in this way, you can reduce that and make the gift of God a little bit less painful. And the last aspect is obviously the carbon footprint, becoming more and more, not only because of environmental awareness that increasing in the world, in the last few decades, but also in the practical terms of getting more business, as we mentioned, from big brand owners, chain stores, and people who actually bring business to this. This reduction effect immediately on the carbon dioxide and methane gases that is emitted to the environment, and thus the printer scores more points.
That's really great. And Amir, what are the newest products from GEW that will help converters accomplish these goals?
So, GEW went into LED curing system about 10 years ago. And quite frankly, we were a little late compared to our competitors in going LED, but the advantage of that is that we learn from their mistakes. So when we came up with LED system about, I would say, 6 years ago or so, it was already well polished and well ready, and all the deficiencies that the early days LED systems were suffering from, we did not. Now, in order to facilitate the broad range of requirement from LED curing systems, we subdivided our system into 2 families or 2 categories. The difference between those 2 families is the cooling methodology. Our lower power, which probably is suitable for all the listeners of this edition of Video Bytes, a narrow web printer runs relatively slow, producing labels or shrinks. Those can be cooled by air. And if you need a higher power, if you do special application, if you do faster speed, if you do hot melts, and you require higher powers, then you would need to use a water-cooled systems. Now, the difference between them is relatively simple. The air-cooled system, which we, by the way, call AeroLED, can deliver about 185 millijoules per centimeter square at 100 meters per minute. This is the amount of energy that actually the web absorb in order to get the inks cured. And the water cooled system, which we call LeoLED, delivers about 270 millijoules per centimeter square at 100 meters per minute, which means that the water-cooled LED can deliver around 30 to 35 more power that is needed when you run faster speed or specialty application like functional inks, like hot melt coating, and things of those sorts.
Great. So from an energy standpoint, what do you expect to see in the future, and how will GEW continue to play a pivotal role in answering that market demand?
So unfortunately, energy challenge is going to be with us for a long time to come. If you look over the history, when they start producing electricity with coal, people said, okay, now all our problems are solved. And then later we know what the deficiency of that and the cost. And then they went to fossil fuels like oil, and gases, and we all know what that produces. And then they came up with nuclear, and nuclear was the message. It's clean. It's this. It turns out it's not so clean. It turns out that it has some issues. Just thinking about what happened in Japan a couple of decades ago. This crisis is still going to be with us. And when we talk about clean energy or renewable energy, which is, by the way, a whole other subject that we can spend another video bites on, the solution is not trivial. So we have to contribute our way to reduce our energy consumption. So in fact, the only thing that is practical from the converter standpoint is reducing his own consumption. And reducing his own consumption, as we mentioned before, can be done while moving to a very low energy or a lower energy consumption curing system. Now, GEW is already active in this market for three decades. And our main drives, we have two main drives in the way we develop our products. The first one is energy. Reducing the energy make the systems much more efficient, make our power supplies, the power supplies are huge power supplies that consume a lot of power. So to make them efficient, means that most of the energy that we take from the outside electrical company would go into curing and not into heat and any other thing that wastes energy unnecessarily and doesn't improve the curing system. And the second thing is automation. Now, automation means saving time. Saving time means that the system are not just on idling, waiting for the operators to do something, to set up something, to tweak here, to tweak there. So in order to facilitate that, we came up last year with our ArcLED technology. Now, Arc is for conventional, LED obviously is for LED. And in this technology, what we can do is on the same press, on the same color station, you can decide what kind of technology you want to deploy in order to cure your inks properly. You can either use conventional or LED, and you only need to do it by switching the cassette. So you take one cassette out, you put the other cassette in, and all the rest of the things are being done automatically. The power is being adjusted, the voltage is being adjusted, everything is being adjusted to the new technology. So the operator does not waste time in doing anything that has to do with curing in order to bring his curing to utmost quality. So this is essentially what we do. We will continue to do that. We have some, we work also on some more efficient LED arrays. We're working on much better production methodologies. We are building now another a big production facility across the street from our headquarters in suburban London, where once it's finished, we will be able to address the needs of the market very quickly, very effectively, and very cost effectively.
That's terrific. Thanks so much for your insight today, Amir. If you'd like to learn more about GEW's newest products and how they help promote lower costs and sustainability, head on over to their website at www.gewuv.com. Thank you.